So today's lecture, we're going to kind of just have an introduction into classes and objects for C Sharp. Now today's lecture is going to be slightly different in that we're going to be talking a lot more about concepts than we are about the actual syntax of C Sharp. Now what I mean by that is I'm going to go a little pretty quick today when it comes to creating classes, creating objects, and showing you things in Visual Studio. And I'm doing that on purpose because in later lectures we're going to dive really deep into classes and objects and the actual syntax. The purpose of today's lecture is because everything in C Sharp is contained within a class, and therefore you're instantiating objects of those classes. So without this introduction, it's kind of hard to kind of get your head wrapped around how we're doing everything, how we're using labels and buttons, and how we're calling properties and methods and things like that. So this is just an introduction. So again, don't worry about the syntax. Just focus on the concepts that we're talking about. So next I want to talk about software engineering in general. Because sometimes when you're getting your degree, you're so focused on just the syntax, just trying to learn in these classes, right? How hard is it just to learn the syntax of C, C++, Java, or C Sharp, et cetera, right? That's a challenge in itself. But it's what you can do with that syntax is what's going to make you a software engineer. And that's what you're getting your degree for. That's why you're going to be worth more money than the next person is because those skills as a software engineer, not because you know the syntax of C++ or C Sharp. So think about this. A lot of companies can ship their work overseas and do it half or a quarter of the cost of what a normal software engineer would charge. Well, those types of projects, the only way that works really well is if you have very well defined requirements. Because a lot of people can read tutorials about C Sharp, they can pick up a book about C Sharp and create programs, but that doesn't really make them a software engineer. A software engineer is someone who has the specialized training to solve problems. A company doesn't hire you because of C Sharp. A company hires you because they have a problem that they need you to solve with C Sharp. There's a big difference. And then again, that's what makes your degree worth money. So for instance, example at Boeing, I'm a software engineer, but it's very rare that a project that I work on is just solved by a software. So I'm also going to have to work with electrical engineers or mechanical engineers in my day-to-day. Now, again, there's going to be other types of jobs where it is pure software, a mobile application or, a web application. Things like that will probably be pure software to get everything the job done, but a lot of applications you have to have, multiple types of software engineers all working together. Also, what I've found over the years, especially with software engineers, is that sometimes we get in the habit of we find a language that we like and we just think that it can solve all problems. And so what I highly recommend is that, well, yes, it's extremely important that you know these different languages and their syntax, but whenever you approach a problem, you have a new program that you've been assigned to, take a step back and say, what is the right programming language for this specific problem? Because sometimes C or C++ may make sense, sometimes it's C Sharp, LabVIEW, Python. There's all these different languages that they have their specific uses. So remember that. Now let's get into today's lecture now. So today, the whole point of today is just so we can understand classes and objects. So what we're going to do is I'm going to right click over here. And again, don't worry about how I'm adding things and syntaxes. I'm just going to kind of, again, understand the concepts. And I'm going to create myself what's called an employee class. Now, this employee class, the reason I'm creating this is because a class, you can think of it just like a blueprint to a house. So what I mean by that is in the real world, let's say there's a developer that's going to be building a whole bunch of different houses in a particular neighborhood. Well, they need to first start off with blueprints, right? You can't build a house unless you have a blueprint for that house. Well, the blueprint is just this syntax that you're creating, the class. Now, think about this. This statement doesn't make any sense where I'm going to live in the blueprint or I'm going to use the blueprint, right? You can't paint a blueprint. You have to create the house before you can paint the walls, lay down carpet, et cetera, et cetera. So it's the exact same within programming. So you can't use a class. You have to instantiate the class into what's called an object. The object is something you can actually use. So the object represents the house, for instance. In this case, we have an employee class, but we have to instantiate the employee class into an object before we can actually use it. And this is such an important concept to understand because everything in C# is object oriented. It means every piece of code has to be contained within a class. So I created this employee class. I'm going to change this keyword to public for right now. Again, we'll talk more specifically about that later on, about what this is going. But this is just essentially says, hey, this class is public to the whole world. Anyone can use this class. Here's the name of my class. I'm going to call it CLS employee for class employee. Again, just be consistent with your class names. Whatever program you're on at your work, you'll come up with naming conventions that make sense for you. So there's other ideas of classes. There could be a customer class. You could have a date class, a data access class that's used to get data from a database. You can have a math class. There's usually a lot of times I have like a miscellaneous class that has different methods in it that are just sort of helpful methods to get things done, formatting or et cetera, et cetera. You can maybe create like a tic-tac-toe class. This will be for one of your assignments later on. So all of the logic of what it means to have a winning move or a tie, things like that would go into the tic-tac-toe class. And so again, a class is just this logical chunk of code that's going to help you solve a problem. And it works out really well if they mimic real world objects in a lot of cases, like for instance, an employee. So we create our employee class so that we can create employee objects that would hold information about the employee. So how do we hold information about the employee? Well, we do things like attributes. So we have, like height, weight, the employee number, social security number, age, whatever it is about this employee, we can create these attributes. And then to access those, we can create things called properties. We can create things called public methods so that the outside world can, manipulate the data somehow. And so let's kind of go through that with our employee class. So before we do anything, whenever you create a class, the first thing you want to do is type 3 forward slashes and make sure you create the class comment. And this is very, very important because someone else is going to be using your class and you want to have comments that's going to help them make sense of how to use your class. So I'm going to write a comment here, just say, employee comment, just so later on I can show you where this particular comment will be used and where it'll show up in the IntelliSense. So the next thing, let's go ahead and let's create some attributes. So I'm going to use the private keyword and we're going to say string sname. Now what this means right here is that I don't want anyone from the outside world to have access or knowledge about this name attribute. Only me, the writer of this class, anything within this class can use the name object, but nothing outside will know anything about it. And again, the first thing you always want to do is write a comment. So this is the name comment. And of course, yours would be more descriptive based on whatever it is. So let's go ahead and create another one, but this one I'm going to use the public keyword so you can kind of see the difference between a public and a private attribute. Now, almost always you want to use private attributes. I think I've never used a public attribute, and we'll talk about how you can access the attributes in just 1 second. But just to show you, I'm going to create one called age. We'll just keep this really simple. Again, always, this is the age comment. So now we have this class employee that has two attributes, a name and an age. So maybe we want to be able to access this data from outside the class. So in order to do that, we have these things called properties. So I'm going to say public string, and instead of sname, I'm just going to call it name. Okay. Now, a property, it's kind of like a method, but it just allows you to control access to your private attributes. And there are more things when we get into some of the GUI aspects and what are called data binding and a few other things that properties are key to use. But for our purposes right here, we're going to keep it simple. And just think of this as a way that you can control access to your private attributes. Now, we don't have to control access to our public ones because anyone can access this. And that's generally why you don't have public attributes. You have private attributes with public properties that can access them. Now, again, because it's a property, it has special syntax. So one, and this is what I kind of love about the IntelliSense here, you can actually see that if I just press get and then tab, it actually creates the syntax for me. And now I can also do what's called a set and do tab. And again, I'm going fast because later on we're going to go into this syntax in excruciating detail. But what I've done here is I've created this property. The get right here just says if I call the name from this employee, when I instantiate an employee object and I say .name, it's going to return the sname value. But if I were to set it equal to something, then sname is going to be equal to value. So it's sort of like this value keyword is how the value gets passed in. Again, in a second when we actually instantiate the employee object, this will start making a lot more sense. But before I go on, I'm going to just say, this is the property comment. Now remember, this is public, and this is private, so those can be seen with outside the class where this private attribute cannot. Next, I'm going to create a public CLS employee constructor. So now a constructor is what's get called when you use the new keyword in C# to instantiate an employee object from this employee class. Now, you don't have to have a default constructor, but sometimes you want to, set these to something meaningful. For our purposes, we'll just do this really easy, and we'll just set these some default values. You can also have non-default constructors where someone can actually pass in the values to instantiate these. But for our time being, I just wanted to create this so that you can see later on when we instantiate an object of class employee, this is the first thing that gets called. Essentially, it just starts your class, your object from this class. You can initialize things, and you have control over what you set in here. Now next, a lot of classes we need to do something with our data. So I'm going to create a test method here. And I assume the syntax probably looks extremely similar to Java or C or C++. And in our method, we're going to have something we're just going to say sname, and we're going to just concatenate on a space, and then we'll do iage.toString, something like this. Again, a method that doesn't really do a whole lot. This is the method comment, and this little attribute here, we say return name and age. So we can actually comment what this method is going to return. So we've used the public keyword, which means that outside of our class, someone can see this test method, and when they call it, it's going to do this. Now what I'm going to do is I'm actually, just for our purposes, I'm going to do this, say, private test method, and I'm going to change this to private and leave the syntax there. And later on, I'm going to show you that we can't have access to the private test method here. So now we want to talk about how we're going to actually instantiate this employee class object from our form. So I'm going to come over here to my form, just go behind this, and right now we'll just kind of use the constructor here, and we're just going to kind of play around with some of the code. So what we want to do now is we want to actually instantiate objects of our class employee. So remember, this right here, all we did was create our blueprint for our employee. This is the blueprint that we're going to now create the house from. So let's create some employee objects. So CLS employee, just like you do any other variable like string or int, but now I'm going to create my object reference. So I'm going to say my employee 1. Now what I've done here, this is actually just an object reference. This right here. This is just a place in memory that's going to then point to where our actual object exists. So again, this is a place where most people will really kind of get confused. This is not creating an employee object. It's creating an object reference. Now, in C# we don't have things like pointers like C or C++, which is very nice. But behind the scenes, it is still dealing with addresses and things like that. So that's what this variable or this object reference, it would hold a reference that points to where your actual object is stored in memory. Now what I'm going to do is I'm going to create a second employee object that we'll also be using later on. So now we have two object references to our employee. So now what we have to do is we're going to CLS, we're going to say myEmployee1 equals a new CLS employee, and you can see it finishes the syntax for me now. This is the equivalent of actually building the house. This actually creates an object of type CLS employee. So this is the object reference. Now we've filled up the object reference with a pointer to that object. But again, we don't use pointers in C#, but now we've actually instantiated the object here. Well, now that we've done that, we can now use our object. So I can say CLS, my employee one dot, and watch what happens with the IntelliSense. So just to remind ourselves, let's come back over here to our employee. We have a private name. So let's see what happens. Let's see if we can access S name. So if I come over here and say dot, now you'll notice that there's no S name here in our list, but there is a name. So what was the name? The name was our public property. And right here, here's that comment that I wrote. This is the property comment. So if we came over here, this is the code that is getting accessed, and that was the comment that popped up. This is a property comment. So again, that's when you hear me keep talking about why we have to use XML comments. This is the reason. So IntelliSense, and also you can reverse engineer your code into designs and things like that. So it's very important to always use XML comments for your attributes, your properties, your constructor, methods, etc., etc. So let me go ahead and open this back up again. You can see there's name. Now we got this equals method. We're going to talk about this a little bit later on. Here's our test method. Now you can see this is the method comment. So someone who doesn't have access to maybe I just gave someone a DLL that contained my class, but they don't have access to the code. So they just have this comment that tells them how to use this method or what this method does. That's why it's so important to make sure your comments make sense to other people and not just yourself. Now there's also these other methods that seem a little strange. Get type, get hash code, equals, get type. We're going to come back to those in just a minute. Now we also have iAge. Now this was a public attribute, right? So here's our public attribute, and that's why we can access it directly from outside our class. So if we wanted to, we could say age, equals 23 or whatever we wanted like that. And we can also access, my employee dot, and you notice there's name equals, ABC, doesn't matter. So now we've instantiated our employee object, and now we've set the two values. So now our object is now taking shape. And again, you could have hundreds of attributes, hundreds of methods that all make sense, encapsulating what it means to be an employee. Now the last thing we want to do is we're going to call our method. So I'm going to say CLS myEmployee1 dot get test method. And you can see now here, this is the method comment. So if we come back to our employee class, let's try to access this one now. So this one was private. We just saw that we can access this one. But let's go to our private method and let's see what happens. So you can see dot, and now nowhere in here can you see our private method because it's private. It's meant to be used internally of the class, not externally here. But we can call test method. And again, I can highlight test method. You can see that here's the comment right below it. This is the method, and it returns the name and the age. So it's really important, again, look at those XML comments about what it tells us on how to use this code. So what I'm going to do now is I'm just going to set a breakpoint right here. We're going to run our code. And here we go. We hit our breakpoint. Now, what was this CLS employee? Well, this was our constructor. So if I press F11, it's going to then step into our constructor, and then it's going to initialize our class, what we set it up now. Now here's iAge. Now iAge was just a public attribute, so it's just going to set that. Now name was a property. Now sometimes you'll see this. So I actually pressed F11, and in Visual Studio, I believe it defaults that a lot of times it's just going to step over properties rather than step into them. So I just wanted to show you that you can actually override this, and it'll show you each time. But in the debugger, you can go to Tools, Options, and change this. It's kind of up to you how you want to do it. So let's take a look at our test methods. If I were to press F11, it's going to step into our test method. And now we could debug it. We can see our age is equal to 23. The name is equal to ABC. Press F10. It comes down here. And now here we go, ABC 23. So that ends up being, how our object works. Now, what you want to be really careful of, and I see this all the time, is where, let's use our employee 2 now. Now, if I do dot, you can see that everything still pops up just like before. But what am I doing right here? This statement doesn't even make sense if you really think through it. And notice the compiler, I haven't even built it yet, but Visual Studio is like, hey, there's a problem here. This doesn't make sense. And you can see use of an unassigned local variable. Well, why is that? Well, remember, all we've created is the object reference. There is no house yet. There is no spoon, as Matrix would say. What we've done here is all we've said is we've used our blueprint and we've tried to set a name. We've just written on a piece of paper essentially. We haven't actually instantiated the object like we did here for our employee. So what could actually happen, I mean, a way to get to actually break the code, and I see this all the time, is something like this, and then age, whatever it is. So what's going to happen is that when the code hits this line of code, let's just go ahead and do that. Go ahead and run it. You see how it actually throws this exception? Object reference not set to an instance of an object. I see this error all the time. It's probably one of the most common errors you'll ever see. And it is exactly what it tells you. Object reference, so this is an object reference, CLS my employee 2, was not set to an instance of an object. So all you were trying to use your object reference, you didn't actually have an object within this. So again, that's why it's so important that you need to understand the difference between object and object reference. And so anytime you see that error, you know that somewhere you forgot the new keyword. And this happens all the time. I've done it 1,000 times over the years, and so will you. So let's kind of go back now, and let's take a look at our method here. We've created these class level attributes. So our class level attributes can be used in all of our methods. So if I were to come up here, so sname for example, if I come down here, you can see sname. I can reference sname and set it to a value. Down here, I can set sname to a value because it's a class level variable. Therefore, all of my methods have access to that. Now, why would you want a private method? Well, to do some sort of internal work for you. So for example, this test method may call this private method to do some sort of special work like this. So that's why you may have a private method. The outside world doesn't need to use it, but you need to use it internally. Now, these are all class level attributes. They can be used anywhere within our class, but now if I want to create local variables, I can do this, int I. Now if I come down to this other method and I type I, you can see that it doesn't have access. Only this method here, if I type I can then assign a value to it. So this is a local variable, and it only exists between here and here, where these class attributes exist for as long as that object is alive. So again, just real quick to cover what we've gone over today. Public class employee, this is just our blueprint. This is the definition for an employee. We can't use the blueprint. We have to actually create an object reference. Then we have to assign that object reference. We have to put an object into it before we can actually use it. And again, later on, we'll talk about the very specific, we'll go over all this again with the syntax and stuff. I just want you to understand what objects and methods and attributes are really used for. So the next thing we want to talk about is something called inheritance. So what inheritance allows us to do is so we don't have to reinvent the wheel. So we can inherit a bunch of code that someone has already written for us. And it's really nice the way object-oriented programming works with inheritance. So you'll notice that we've actually been using inheritance all along. I just have, kind of just not talked about it. So what we've said is we've got this public class called form1. Now when we create our employee class, you'll notice that nothing over here shows inheritance. Nothing over here has this little colon. So form1 inherits from the form base class. I can actually right-click on this method and say go to definition, and it brings up this metadata for this class, public class form. So there's not actually any code in here, but it's just more, just it's going to have all the comments. Oh, I guess this one actually does have the code. Sometimes it'll bring up just the comments, but so it's kind of interesting that you can actually see all of the work that someone did to create this method. So someone decided, hey, I'm going to write what it means to write a form. But before that person did, someone said, I'm going to write a class called container control so that whoever writes the form can just focus on form stuff, like the bounds of a form and the properties and everything of a form. But I'm going to do the job of a container control. So here's everything that someone wrote code for a container control. And you can understand, look how complex this is. And again, this is all that code in the .NET framework that you're getting for free. Someone also wrote a class called scrollable control. So we can go to definition of this. and you can see everything that it meant for a scrollable control. And you can see how one class is inheriting from another, and you can go all the way up, and at the very end of everything you're going to see that it goes to something called the base class. So in C#, everything derives from what's called the object base class. So as you go all the way up, kind of the same thing here, and this is going to derive from the object base class. Now, because everything in C# automatically derives from the object base class, if I come over here to my employee class, it's exactly the same as if I did this, but it just happens to be there by default. Now, if I go to the object base class, and let's take a look here. Now, notice some of these methods. Do they sound familiar to you? Equals, get hash code, get type. So if we come back over here, let me delete this. I say dot, and here, sure enough, there's equals, get type, get hash code. So the reason we're getting that stuff for free is because someone already wrote what it meant to be an object, and we were inheriting from that object base class because everything derives from object. So those are some of the key components of object-oriented programming. I recommend that you create some classes like this and just sort of get familiar with how you use them, call attributes and methods, and from here on out, I think all the syntax will start making a lot more sense as we learn the various things. Thank you.